We're going to talk about differentials. Differentials are ways to estimate using calculus. So we're going to estimate some real values. This is called differentials. And differentials are DIF. That sounds like derivative a little bit. So let's try dealing with that. So it's a way to approximate. Now, you could use a calculator on some things and you wouldn't have to approximate exactly. I mean, calculators approximate, but this is a quick way to approximate. So let's say we have f of x is x squared. And we want to find out what f of 3 is. So f of 3 is 9. Okay, nice idea. Well, what if we had f of 3.1 instead? If we took f of 3.1 and did that, we would have 3.1 squared, which would give us 9.61 in the calculator. Now that's a literal value. That's great. It's fine. But what if we wanted to approximate it instead? So here's what we're going to do. Approximate using differentials. Differentials are just kind of a slick way to do this. So we had basically 3 both times. So we're going to let x equal 3. And then here, this one is not exactly 3, so it's kind of off of 3 a little bit. So we're going to call that delta x, and we're going to say that's equal to 0.1. Okay? So the formula for differentials is this. F of x plus delta x is approximately equal to f of x plus f prime of x dx. Now the weird thing about this is delta x is literally going to be equal to dx. X is 3. So our function is f of x is x squared. So f of 3 plus 0.1 is approximately f of 3 plus f prime of 3, then dx is 0.1. Well, f prime of x is 2x. That's an easy one to differentiate. So I'm going to go ahead and put some things in here. This is going to be 2x right here. This is going to be x squared. So f of x is x squared, so this one's going to be 3 squared plus, now f prime of 3, that's 2 times 3 because f prime is right here, times 0.1. So this is 9. This is 6 times 0.1, 6 times 0.1, which is equal, I better put that in parentheses, is equal to 9.6. Now notice how close our estimate was, and I didn't really have to multiply that. So that's what differentials can be used for. And one of my favorite ways to use them is to approximate things like square roots or cubed roots. So here's one that's pretty easy. Let's approximate the square root of 48. Okay? I am going to say that f of x, my function, is a square root function because this is a square root. So square root of x. Okay? Now, I know the square root of 49. I have to think about that, but which one do I know? I do not exactly know the square root of 48, but I do know the square root of 49, and I know that that's equal to 7. And I know that 49 and 48 are really close to each other. How close? Well, that would give me my delta x. Delta x is what takes 49 to 48. Well, that's going to take it by -1. So that's my delta x, which I'm going to call dx. Okay. So if I try to find the square root of 48 on the calculator, I've got a calculator, I'm going to put square root of 48, and so the actual estimate, actual calculator estimate, it's not an actual value, but it's a calculator estimate, is 6.9282. Okay, 4 decimal places is probably enough to deal with on that. Let's look at what we're going to get with a differential. So if f of x is square root of x, let's say that f of x plus delta x is approximately equal to f of x plus f prime of x dx. That's the same formula that you see written in books and such. That's generic. Now we put ours in there. So f of x is square root of x. So this one's square root of x plus, okay, now f of x is the square root of x, which is x to the 1/2. So f prime of x is equal to 1/2 x to the minus 1/2, or 1/2 square roots of x. So I'm going to put that in here. So I've got 1/2 square roots of x. Then I've got to put dx. dx right here. Okay? So here's my formula for this particular function. So f of x plus delta x, which we want to say is the square root of 48 because it's 7. We've got 7 here, and then we've got our delta x. So I actually have 49 here. So 49 minus 1 is 48. Okay, so not the answer, but the value I put in. I know that x is going to be equal to 49. So x equals 49, and delta x equals minus 1. So let me go ahead and stick these values in. I've got the square root of 49, that one I know, plus 1/2 times the square root of 49 times -1. So what I've got is square root of 49, and then I've got minus 1/2 square roots of 49. Let me put numbers in there. That gives 7 minus 1/2 times 7, or 7 minus 1/14. Now, if you want to do fractions, you could. 7 with a 14 as a denominator would be 98/14. Minus 1/14 is 97/14. Now, that's not exact. I mean, it's exact for our estimate, but 97 divided by 14 on the calculator. Take a look at that. 97/14 is 6.9286. So we put a number in the calculator and had an estimate, and found the square root of this. So the actual calculator estimate for square root of 48, 6.9282. The differential estimate, 6.9286. Pretty close.